welcome to the shop. Today we're going to be talking about how to set your MIG welder so you can stop turning knobs and get onto your project. If you haven't tuned in before, my name's Tim and my channel is all about making welding simple. So if you like what you're seeing, go ahead and click that like button and subscribe below. Let's get started. Okay, let's start out at the whiteboard to talk about a few of the fundamentals. So the settings you have when you're welding MIG typically are wire speed and voltage. Sometimes there's some others, but we're just going to worry about those because that's what you probably have. And wire speed is what we're going to set first, and we're going to set voltage second to match it. And the wire speed will mostly be based off of the material thickness, and it will control your heat, basically. The voltage needs to be set to get the right transfer mode. Now, the transfer mode has to do with how the wire that comes out of your MIG gun interacts with the metal below, okay? And there's not an arc lit all the time if you're welding what's called short circuit transfer mode. And that's probably what you're doing if you're just getting started with welding steel. If you're welding aluminum, you're gonna have spray transfer, so it'll sound a little more like a hiss, and that'll be a little different, but the principles still apply in this video. You're just going for a little bit different outcome with regards to your transfer mode. But for most of us, we're gonna be welding short circuit transfer MIG. And what happens there is the wire comes out when you pull your trigger, it comes out of your MIG gun, and it'll contact the metal and it'll get hot because the electricity going through there will heat up the wire from electrical resistance, and then that will melt off and you'll form an electrical arc between the workpiece and the wire, and then it'll keep getting longer as the wire melts off and longer until it's long enough that the voltage can't maintain an arc over the gap between the workpiece and your wire, and you have a new gap opened up, and the wire feeds down till it contacts the metal and starts the process over again. And it's important to recognize that voltage and wire speed have to work together in this way so that you get the right transfer mode. And that's why when it's running right, it'll sound like this. Alright, so we're going to set our wire speed first, and we're going to base that mostly off material thickness and the wire diameter. And so you can take a look at this chart here, grab a screenshot. This is based off of some rules of thumb that came out of MIG welding manual from Miller, and I just did the calculations there for you. So this can give you a good starting point. There's also these little slide rule calculators that you can buy. I'll link one of those down in the description, or you can get on different websites. I know Miller Electric at millerwelds.com, they have some, and they also have a mobile app that will calculate some settings for you. And the most convenient place to look really is if you open up the side of your machine. You probably have a chart that'll go based on your shielding gas, your material thickness, your wire diameter, and it'll give you some settings for your machine. And if you're using a machine that doesn't read out wire speed in inches per minute and voltage in volts, it's really just like a 1 to 10 or a 1 to 100 type knob, then it's going to be a lot more convenient to just use those settings in the machine. And every machine runs differently, right? So these settings might not work perfectly for you, but it gives you a good starting point, and the wire speed is the main thing. We'll walk through how to dial in your voltage here based off the wire speed that you have, and we'll just do that on some scrap metal, running some test welds. But before we do that, just want to make one note. If you're welding in the vertical or overhead positions, you're going to want to dial it back a little bit. You might go down about 1 material thickness, and that seems to work pretty well for me. So go on the lower end if you're going to be welding out of position, and it's a best practice to dial in the weld in the position that you're going to run. I've got my machine set up here. I've set my wire speed to 60, which is I think where it needs to be, and my voltage I've turned clear down to 2, even though I know I need to be right between a 4 and a 5 on my Miller-Matic here. So anyway, I'll go ahead and start welding, and you can see that the wire is making sort of a machine gun type sound. And what's happening there is the wire is just stubbing out down against the material because the arc isn't able to burn back very far with that voltage. Remember, because it's going through this process where it shorts out and it burns back. and that's not really running the way that it needs to be. So here with the 3, you can see that it's able to keep up a little bit better with that wire speed, and the voltage is burning back a little more, but you're getting kind of the same thing going on. Moving on to a 4, now it's running pretty good. This isn't too bad. And moving on to a 5, this is actually even running a little bit better. And so this is right where I want to be, right? And especially since I'm welding 1/8" thick material, I want to make sure I'm getting some good penetration here. And so 5 is running good. This is what you're looking for. I'm going to keep going, moving on to a 6. It looks like you're starting to get a little bit of spatter shooting out. Because remember, the voltage is going to control how far that arc burns the wire back. And so you're starting to get a long arc and a little bit more sporadic activity going on there, and you're going to shoot some material out. So that's one, you know, telltale sign that you may be running too hot. Keeping going here to a 7. It's just getting worse. Then here at an 8, all we have going on is, you know, it's not even shorting out, it's just making a mess. Let's take a look at how the welds turned out. So let's start here with our voltage setting of 2. You can see how it's just piled right up on top. It didn't have a lot of heat getting in there. It was really just kind of a mess. Getting on, it's just looking better with 3, 4, 5, and 6 all look pretty good. Now 7 and 8, right, you can tell they were running a little bit hot because that arc was extending out. And you see all these big BBs of spatter. Those are from those welds, you know, a little from 6, mostly from 7 and 8. And it's up here because I was tipping my MIG gun back a little bit, hoping that the camera could see a little better. Anyway, the cool thing here to notice though is really 4, 5, and 6 all seem to run okay. 5 right here is where I want to be. Okay, so once you've dialed in your voltage and you have it running pretty well as far as the short circuit transfer mode goes, then you can take a look at the weld and see if it's heated up on top, then it's probably too cold and you need to turn the wire speed up and then compensate for that with the voltage going up a little bit and dial it in again. On the other hand, if it's sinking down below and burning through your tubing or plate, then you're going to need to turn the wire speed down and also turn your voltage down a little bit and dial it in there. And so once you go through that process a time or 2, you'll get to where you're doing it really fast and you'll be ready to run. So hopefully you learned something here. If you liked this video, please click the subscribe and the bell notifications below, and we'll see you next time.